Hello, تسمعوني؟ Hello, تسمعوني؟ Hello, تسمعوني؟ So, that's dealt with. Apologies for the delay. Gabriel, what time do you have your lesson? Four PM, plenty of time. Bombi Ammar kellu l-tijaj mixawl. So, I do understand that some students might have lessons. Apologies for the delay. It's been sorted, I think, now. With regards to lessons, when I was preparing for this lesson, I know that some students actually asked that the lesson would not be today because they have other commitments. Unless they are school lessons, I would not be in a position to change the times. I'm not going to tell you you're going to have a lesson every Monday at this time, but I'm just telling you school lessons will be the priority at the moment. Now, I'm also preparing videos. So, for example, today's lesson is something where I will have a 5-minute video for these slides. 5 minutes should be enough to go through the slides and finish off the lesson. Of course, without any questions. Now, that is not something that is normally possible. So, please do stop me. I will repeat myself as a normal lesson here. But then I'm gonna record the slides and record me speaking so that you can actually hear it at one go as one explanation for 5 minutes. Later on today or tomorrow morning, I will also be speaking to the class reps to explain exactly what's going to happen with regards to the lessons, because during the two lessons this morning, there were a few things that I had a few ideas, so Claire, I will just be speaking to you later on at some point. Now, there were some students who asked me what I had with respect to health. I had the common flu. So it was just a normal virus. I was sick. I had a fever of around 103 at some point, but it was just the common flu, okay? So don't worry about anything else. Now, exams. I think most students have sent me an email to see their mark for physical chemistry. A few have not. Now, I don't not oblige you to ask for the mark, because that mark is something that is yours. At some point you will get the papers and you can see it for yourself. The truth is this: I ask you to ask for the marks because I can guide you. There were some students who I told them I will be sending a few more questions. Apologies, I haven't done that yet since last Tuesday. Today is the first day. Okay, brilliant. But today is the first day where I can actually okay, no problem. Personally, it wasn't just a division of the marks that I was giving you with regards to my section. There were some students who know that I gave you a background of what you could prove, where you can do better. For the G, you did really, really well. Good job. I haven't seen the paper. Okay, so I don't know if it was hard, easy, or average. But you did really, really well. There were some students without the G, they would have struggled. But important, if you passed and you got one section 18, 19, or 20 from 20, and the other sections you didn't do that well, improve on the others. Don't know what's gonna happen, so students have asked what's gonna happen for the annuals. I don't know. I hope we'll be back at school in a month's time. That is the earliest we can be at school. For now, I would like to just speak about dative covalent bonds. Is there any one of you, now this is a question where it should be simple and all of you should know it, but is there any one of you that is not sure that a covalent bond, covalent here, not dative covalent, a covalent bond is the sharing of two electrons. So a covalent bond is the sharing of two electrons. We've never actually discussed what those two electrons are, where they come from. We just say that this is the sharing of two electrons. Now, this is crucial when we're speaking about dative covalent bonds, because if you know that it's a sharing of two electrons, there are only two possibilities. You can either share two electrons equally, so one atom gives one electron each, or else it can give two electrons not equally, or that would mean that the two electrons are being shared by the same atom. Okay? Now, so a dative bond, a dative covalent bond, is a special type of covalent bond in which both the shared electrons are contributed by one atom only. If you have nothing better to do with your life, I don't think you should be on this YouTube stream passing comments. Now, it can then thus be defined as a covalent bond in which both electrons of the shared pair are contributed by one of the two atoms. Important, there's a difference between a normal simple covalent bond and a dative covalent bond, and this is the difference. The electrons are being given by the same atom, okay? By one of the two atoms. That's an important distinguishing feature, because now, because we changed the syllabus, now you might have realized that we're not going to do any physical chemistry this year. I'm only going to be doing an organic chemistry with you, so I'm only going to be doing aluminium, transition metals, and that would be till the end of the year. Those you don't have in the pack of notes, so those are on organic chemistry. I will be sending you notes, okay? So I'm going to be sending you videos, I'm going to be sending you PowerPoints, and I'm going to be sending you my personal notes that you will be studying from. But these are not in the notes for physical chemistry. Okay? Let's make that clear. I will be sending you the notes probably later on during the week or next week. First I'll send you aluminium, then I'll send you transition metals. Transition metals are not easy, but I think it's a blessing in disguise that you're going to be doing them in first year. Now, during the online lessons, make sure you understand. Now, that means some students would need... Yes, I will. I mean, this PowerPoint is not mine. I've already sent it to the class rep, but I can send it on Facebook as well. Some students understand better when they write notes, others don't. So I'm not going to tell you don't write notes, but it's important to just understand. Okay? Now, this PowerPoint is a communist PowerPoint, okay? I'm sorry, I didn't realize, but it's amazing when it comes to native bonding. So, such a bond can also be called a coordinate bond. So, pretty much when we mention native bonding in aluminium, especially in aluminium chloride, where it dimerizes, we're going to call it a dative bond. In transition metal, we're going to call it a coordinate bond. There's no difference. It's just that different scientists prefer to use the different wording. Okay? But they are exactly the same thing. So dative bonds and coordinate bonds are exactly the same thing. You can actually interchange them, but normally they end up being used for slightly different uses. So, a coordinate bond requires two things. It requires two atoms. Okay? Now, these atoms could be a part of a molecule, could be part of an ion, but it requires two types of atoms. The first atom is an atom that has a full outer shell and a non-bonding pair. A non-bonding pair we have described as a lone pair. The second atom is an atom where you have a pair of electrons short from a full outer shell of electrons. Now, do you all remember what an electron deficient compound is, or an atom which does not have 8 electrons, it has less than 8 electrons in the outer shell after covalent bonds? Do you remember that from bonding? When we were doing VSCPR, there were quite a few. Okay, so Emma, Al is one of them, okay? Al, Be, boron. So if you were to draw aluminium chloride, you will not get 8 electrons on the outer shell. You'll get 6. If you were to draw beryllium chloride, you'll get 4. So these type of atoms, again we're speaking about the central atom here, they would require more electrons. Okay, so they are called electron deficient. Now, just because I know that some students might be doing these at private lessons. First and foremost, what we're doing here, you're not going to cover this year in private lessons. I highly doubt. But you might also mention, if you do acid and bases, things called Lewis acids, Lewis bases, and Lewis structures. Normally, it should have 8 electrons. Okay? So, a full octet is 8 electrons. Now, aluminium chloride. Yes, I know, but that video is not me explaining. I'm giving you other tools because I want to make sure that you have to understand them. Now, Lewis acids, or ligands هنعملوهم. Lewis acids, we will be doing them next year in acids and bases. Not important, but acids and bases, the introduction is to define what an acid is and what a base is. And one of the definitions is the Lewis acid, Lewis base. It's not that they're not important, they're very important. They're not important for now. Now, are we all clear that we need 2 types of atoms? And these atoms, you can see A has a 4 octet and it has non-bonding pairs. Definition of what? And B, I did not give a definition, Gabriel. I just said they're not important for this year. I did not give a definition, Gabriel. I just said they're not important for this year. Tipo, no definition for now. B. Scusami. B has 3 pairs of electrons. Ask me, Luca. And it has 1 empty orbital, so this is electron deficient, it needs an extra pair. Tell me, Luca. No. These do not represent anything. A is A, B is B. A is an atom that has a 4 octet and at least 1 non-bonding pair. B does not have a 4 octet. It requires one electron pair to get to a 4 octet. This is not aluminium chloride. Issa, we're gonna do examples later on today, okay? But this is just what you need. So A can combine with B. I know. We're gonna do examples today. So تجريش. A is gonna combine with B simply by giving 2 electrons to B. And that you can draw it like this. Now, how many times have I told you not to draw the shells? Pretty much not yet, okay? Because I was waiting for the Lewis acids, Lewis bases lesson, and then I would tell you how to draw a Lewis structure. Because we're not doing this diagram can be drawn without drawing the shells. Actually, it's a bit better not to draw the shells. And without drawing the shells, you can draw it like this. There's a small difference from the previous diagram. Because both electrons are coming from A, we can replace that lone pair and draw an arrow. So in organic chemistry, you have learned that moving electrons, you can do it by moving electrons with an arrow. And each arrowhead signifies 2 electrons. So here what we're saying is A is giving 2 electrons to B. Because it's the bond, you know that the electrons are gonna be present here. Okay? That's what we're saying. Important, take note, because this is very, very, very crucial. Now, the atom which contributes the electron pair is called the donor. And again, a donor is normally something that gives. Okay, so donor is giving electrons. No, Xenia. Even here, I'm gonna say that you can draw dative bonds without the arrows, but it's just to show you what's happening. You draw the arrow to show what's happening. Normally, don't draw them with half arrows because it doesn't make a lot of sense. Remember, you have done that with the half arrows in the theoretical mechanism. When you make a covalent bond, you do half arrows. Okay? But then you draw the bond itself as a single bond. Claire, yes, this would work with VSCPR. These would definitely work with VSCPR. I will give you a few to draw. I will give you a few examples, okay? You'll have some work. Not today, it will probably be tomorrow. The atom which accepts is called an acceptor. So if you donate, you're a donor. If you accept, you are an acceptor. Okay? So nothing too major. This is just the English language. Okay? Donors donate, acceptors accept. And a dative bond once formed, is indistinguishable from a regular covalent bond. This is important. It is indistinguishable from a normal covalent bond, and therefore you would not know where the electrons actually came from. This is why sometimes we notate the arrow to show that they came from one particular atom, not the other. But in reality, once you actually form the bond, it makes no difference. So, what is a compound formed via dative bonding called? There are quite a few names. It could be a coordinate compound. Again, it's a coordinate bond. An addition compound, because normally you do this by adding two molecules together, or an adduct. These, again, just because you might be seeing some other videos, I might be sending you some other information, be comfortable that there could be different notations, because different notations mean the same thing here. Okay? So not to get you confused. They are exactly the same thing. Mela. Luca, now we're gonna do two examples. The first example will be between a nitrogen compound and a boron compound. The nitrogen compound we normally use is ammonia. All of us can now, yes, tell me, Emma, before I start this. Yes, tell me, I'm here, I'm listening, Emma. Addition compounds or adducts. Again, this is not that important to write now, but in reality, if you want, I just gone back because we have some time. But so by this point, you should be able to draw ammonia and to draw boron trifluoride. Yes, of course. Now, when you are drawing ammonia and boron trifluoride, please don't make mistakes. And you should get this product. So ammonia, you have 3 single bonds and a lone pair. Boron trifluoride, you have 3 single bonds. What happens? The ammonia has a lone pair that it can donate to the boron, and we draw it like this. Now, Luca, can you see why I've told you it's not aluminium and chlorine and aluminium chloride? Because aluminium chloride, sorry, I didn't see it. I'm coming back to it. Aluminium chloride would be similar to the boron trifluoride, okay? It would be the electron deficient compound. It normally happens between compounds. It could happen between ions. Sorry, oh, thank you, Amber, I didn't see it. It could happen between ions, but normally it happens between compounds, okay? Because elements, as elements, they normally do simple covalent. I don't think there is any element that would actually do a dative bond. Welcome. Yeah, that's the one that we're going to be doing next, Amber. So, are you all clear to what's happening in ammonium boron tetrafluoride? Now, that would be a compound on its own. To draw this compound, you can use it. I think it is very difficult for just elements only. I think it's very difficult. I can't say it's impossible because I'm not sure. I think it's very, very difficult. Okay, so if you were to draw this compound using VSEPR, you might miss the dative bond. You might or you might not. You might miss the dative bond because you might give the boron an electron, giving electron to nitrogen. In reality, it should not be the case. In reality, you should be able to realize that the boron there would have had too many electrons of its own. Okay? But if you want to draw these as a shape, now, yes, it would be two tetrahedrons on top of each other. Okay? And if you want to do it, you can try it out. So, again, the ammonium ion, as you have clearly described, is a dative bond. I know that some of you have done this at O level as well. I don't normally recommend it at O level, but the hydrogen ion has no electrons. Okay, the hydrogen ion is pretty much a proton. I'll tell you, Emma, let me explain this and I'll get back to it. So whoever needs to leave, I know you said you want to leave by 4 as well, but whoever needs to leave from the others would be able to leave a bit earlier. Now, and it has no electrons except alone permeated by the nitrogen. So, what happens? Ammonia, H+, the full octet of H+, is actually 2 electrons. So, by giving the 2 electrons from nitrogen, it forms the full octet of the hydrogen, and you get the ammonium ion. Now, yes, because it only has 6 electrons. So, let's not do the hydrogen one here. Boron here has 2, 4, 6 electrons. Because it has only 6 electrons, not 8, it would be electron deficient. That's what I want to speak to the class reps tonight, Andrea. Where I want to try and make the videos a bit quicker, and then we might have a session after each video where you can ask, but I need to give you some time where you can actually rewatch the video first. Now, Emma, if you want to find the shape of nitrogen here, you have to do it individually. So first nitrogen, then the boron. Both are tetrahedrals. Okay, so both have steric number of 4, they have 4 atoms attached and no lone pairs. Okay, now this is what I wanted to do today with regards to dative bonding. Dative bonding is actually very important because for dative bonding we're going to be using it a lot in the next few chapters. Now, let me explain, so whoever needs to leave can leave. I want to explain what we're going to be doing next. I want to reassure you that with regards to the syllabus, we're not going to fall behind. Actually, the plan is to try and hurry up a bit. I want to finish transition methods, which I think is one of the heaviest topics in chemistry. I want to finish it this year. If we do go back to school, yes, Jordi, if you do go back to school, again, at the moment we should be entering on the 21st of April. Okay? But no, I'm not gonna hurry up, Maya. Not at all. I intend to give you a little bit more material than the normal 3 hours we have in class. So I know that, for example, you have the Easter holidays coming up. It's not my intention to stop for 2 weeks during the Easter holidays. We've wasted enough time because of this virus. We've wasted enough time because we wanted to settle everything down. and I would like to keep on giving you material. Okay, the material is not to just hurry up. The material is to actually help you out understand the chapters step by step, bit by bit in your own time. I would like to finish Resident Metal before summer now, so that when we come back to school next year, if it's with me or with another teacher, you would be able to go through it relatively quickly anyway, because it's not a chapter where you just do it online and you know that you know it. With regards to lesson times, they're not gonna be long. I don't want to spend 45 minutes an hour doing straight chemistry, because that's too much. With you not being able to ask constant questions, a 30-minute lesson would normally incorporate at least a double lesson. So what I've realized at university, students where I have 2-hour lectures, I can do that on the same lecture in around an hour online. Mainly because I don't need to stop to make sure that everyone has understood. Because you can just rewind, you can play with the videos. The videos, I'm leaving them up online. What I'm going to be doing as well with these videos is this. I will be having a video of every lesson here, okay, where I'm just doing the slides and covering them and just explaining the slides from start to finish. For today's lesson would be around 10 minutes. We have lost time, mainly, first and foremost, we haven't done all the exams. Secondly, in my opinion, whilst we're still supposed to have the exams right now, I think it will finish around 10 minutes. Taluka. What's happening right now is that every lesson is different. Whereas in class I can look at your faces and see if you're understanding or not, here I can't, so I would have to repeat myself. For me, the important thing is not whether or not I cover 20% of the syllabus in the next 2 months. It's that whatever we cover, you understand. It doesn't matter if we do a few lessons in summer for me, as long as we've covered everything I had to cover and you understand it. In fact, it is the reason why we're not going to be doing any physical chemistry. Because for physical chemistry, I would need to see what you are working. And if I can't see you're working, then I can't assess whether you're getting them right or wrong. Aluminium, tomorrow I intend on actually giving it a good go at not finishing it, but at covering most of the topic. And then I would like to spend time with every class actually going through it bit by bit. So tomorrow during sports, I think you know by now, we're going to be doing aluminium. There is enough time in that hour and a half to actually cover aluminium from start to finish. Doesn't mean that we're not gonna do it in detail or do it well. It's that I would like to go then and speak to the classes, individual classes, and see what you've understood. That's gonna be done in 2 ways. First and foremost, I will be giving you quizzes. That's the only way I can think of where I can actually give you a question, you answer it, and I have real life data. Secondly, I would like you to give me feedback either through email, Facebook chats, Facebook group, whatever you feel comfortable. Facebook group for me is the best way because other people can say, I agree, I don't agree. Emails are great because emails are they are on the school server and they're great. Facebook chat is the least preferred option, to be honest, to communicate with me at the moment. But if that's what makes you comfortable, then I'm not gonna stop you. Just be comfortable. We need to pull the same. هذا بالمالتي because I think it's better. عنا بżonn نجبدو ħabel wieħed għax dan iż-żmien mhuwiex żmien faċli. I hated studying when I could actually go out. Having students logged in site for 2, 3, 4 weeks is not the ideal scenario to motivate students to work. Okay? So we need to work together, we need to work as one team. The marks, let me speak about the marks right now. So you have a breakdown of how you've done in all topics. I think from your class I was highly impressed. So when I told you I was happy, I meant I was happy. I wasn't just shutting you up. Now, there are some students who can improve further. Okay? But you need to work as a class. If your class average improved by a mark, and that's how much it improved between November and now, and some students reduced their mark, then as a class you need to work together. Motivate each other. It's not just the teachers that need to motivate you. You need to help yourselves. Look at your friends, speak to your friends, video chat with each other, keep yourself safe, keep yourself motivated. There will be times where we will be able to go out. At the moment, that is not the time. Again, looking at the marks, most students improved. Now, there are some students who I expected you to do better, where I have spoken to you, I have told you my thoughts. Please take them, okay, and take them on. They are important. That was important advice. There are some other students who I'm happy with their mark and maybe you're not. You wanted to do better. Fine. Prove me wrong. Happy with your mark doesn't mean I wouldn't be happier if you do better. Happy with your marks mean that you've improved. And at the end of the day, the most important mark will be the one you get next year. Don't let these couple of months ruin your expectations for next year. Next year should be a great year, it will be an awesome year, and together we can make sure that all of you can get the grades you require. Okay? I think we can stop here for today, unless there are any further questions from your sides. If there are, please do not hesitate to ask. Okay? I will see you all tomorrow at 1:15. Since this seems to have worked relatively well, I think tomorrow this is what I will be doing. Challenge accepted, Xenia. Never say that. Fate has a way how to ruin those type of comments. Okay, I will see you tomorrow, guys. Thank you.